On the homework. Questions? No questions. Everybody understands all that stuff. That should be pretty easy. Stuff we're going to do from here on out for the rest of this chapter is a little tougher. A little more involved. A little more useful problem. Simple interest. Again, we should, this assignment's not real long, so you should have time to get it done while you're in class here. If Carly uses her brain a little bit, there's a poster right above her head there that tells the simple interest formula. She can't remember it. Bad thing is that only part of what we do is going to be simple interest. We're going to hopefully simple interest isn't something that's real hard to figure out. Compound interest and things along those lines a little tougher. Matt every now and then help Colby out. Hey Colby, we're in class now. You could be writing stuff down. I seen the light bulb above his head just a second ago. Oh, we're actually doing something. So simple interest is the amount of money paid for the use of a lender's money. If we're dealing with a savings account or a checking account, or some kind of account that you have through the bank where they're paying you interest, then the interest is added on to the account. If it's a loan that you have through the bank, then that's extra money that you owe them for using their money. All right, so either way, when you put money in a bank, what's actually happening is that bank is using your money to do other things with. So just because you go today and you put $1 million in some bank account, that money's not going to be there tomorrow. They're using it somewhere else. That's it. Always. If you ever listen to, you'd have to actually talk to some police officers or something. But if somebody robs a bank, stupid. You're not going to get much money when you rob a bank. The money's not there. It's not like the Old West where they had this big safe and all the money was stuck in that big safe. The money's not there. It's all,
It's mostly like online based.
It's all electronic stuff.
Right, that's why you rob an antique store and resell them.
So if you're going to rob something, don't rob a bank.
Take products and resell them.
Rob repaired.
Got it. Thanks for the
Rob
tips.
repaired.
A few years ago, last time I actually talked to a police officer, and there had been a couple of bank robberies in Preble County. I think there was like one in Lewisburg and one in Eaton, and it's been several years now that it happened. And I think each time they got like $3,000. Now, $3,000,
That ain't worth it.
especially if you use a gun to do it, because once you use a gun, then the sentence for holding somebody up with a gun is just like you killed somebody. So it's a life sentence,
Good job.
right? So to get $3,000 out of robbing a bank just doesn't make any sense whatsoever. Okay? The money's not there because that bank is using that money somewhere else. They're, whatever money you put into the bank, they're loaning it out to other people. That's why back when what you learned in the history class about the Great Depression, that's what caused it. The banks didn't actually have the money, so when everybody went nuts and decided, oh my God, our economy's going to crap, I want my money now so I can put it underneath my mattress and keep it so that it's not getting lost, and everybody rushed to the banks to get their money, and it wasn't there. And that's what caused everything to, or part of the cause, everything to go all crap. So interest, you gotta be careful with interest, because we're gonna talk about different kinds of interest. Again, sometimes you're adding interest on, sometimes interest is a negative thing. Depends on what the account is. If it's money that they're using of yours, then they're paying you interest. If it's money you're using of theirs, then you're paying them interest. So two different ways it could be set up. Simple interest, with simple interest on this, right here, with simple interest, write this down. Simple interest is represented by just an I, and the formula for simple interest is I equals P times R times T. That's a T. Most important formula of this chapter. I is the interest. That's what I stands for. P stands for principal. Not Mr. Eiler. Principal is in the total amount in the account, whatever the account is, whether it's a loan, whether it's a savings account, whatever, just the total amount that's in that account. You can probably guess what R stands for. Anybody have a guess? Rate. It's the interest rate or the percent rate. And T, probably the hardest part of this formula. T is time. And the only reason it's hard is because time always has to be in years. It's got to be in years. So when you're doing time, if you have the account for 3 months, it's still got to be in terms of years. And we'll talk about how to make sure it's in terms of years as we do it. And you should be able to figure it out even with just days. And now, you can't just count on whoever's doing these accounts that their stuff is doing everything right, because now everything's done on the computer. If that computer screws up, and the people that are running the computer don't have any idea, it's just like your calculator. Alex doing the test, Alex is doing his test, and he's using his calculator, and he goes, but that's the answer the calculator gave me. What do we know about a calculator? It's not always right. Because of what? The operator. Same thing with the computer. Right? Don't just count on the computer the fact that it's always doing something right. So you got to be able to or understand how these different interests work. Principal and annual interest rate. Your annual interest rate a lot of times is, if you ever heard APR, annual percentage rate. So again, principal is the amount of money that's earning interest, the total amount in the account, whatever that account happens to be, whether it's a credit card or a savings account, whatever it happens to be. Your annual percentage rate or your annual interest rate, what's annual mean again?
Yearly.
Yearly, very good. Yearly. So it's the amount that it earns in 1 year. Most things, and we'll talk about some of these different ones, a lot of things earn interest annually. So like CDs, not the CD that you put in and listen to music, and that's probably even old now, you guys don't even use CDs anymore. But not that kind of CD, a CD like you're earning money on it. It's like a savings account kind of setup. But they'll earn interest annually. They'll only add the interest on annually. And one of the main things that you've got to always think about, if I have a credit card, so if we have a credit card account, all right, I'll be out of the way in 1 second, or we have a savings account, which do you think gets the interest added on quicker and more times?
Credit card.
The credit card. Because that's money you're paying them. All right? For something like a CD or a savings account, the interest, the money that they're paying you doesn't get added in as quickly. All right? And you always got to remember that. When you have some business, if they're using your money, they're going to pay you for it, but they're not going to pay you for it near as much as if you're using their money. So credit card accounts, a lot of those interests, they get added on daily. They get added on just constantly, all right? And that's something, if you have a credit card, you need to look at it, and it'll tell you how often that credit is added, or how often that interest is added on. Savings account, same idea. You need to look at it and see how often it's added on. Most savings accounts are like monthly or something, but a lot of credit cards are added on daily. Every time at the end of the day, the computer adds on the interest, all right? Now, you owe me this much interest. Then next day you owe me even more, so on and so on. Again, principal, just the amount of money that's in the account. So this is whatever the total is in the account. And your APR, your annual percentage rate, or your annual interest rate, is how much per year. Going with this, we talked about this when we were talking about how often you get paid and stuff. So if it's yearly, then it's like you're getting paid once per year. That's one time per year. What were some of the others that we talked about? how much you get paid. It's sort of on the same setup.
Monthly?
You might get paid monthly. So if you get paid monthly, how many times per year are you getting paid? 12. Alright? A lot of savings accounts and stuff, that's what they do. They go by your monthly balance, and that's what you get paid interest on. Other things, with these accounts, it might be daily. How many times per year would it be if it's daily? So at the end of each day, at some point, they'll have some set time, and the computer will know to add the interest on at 5 o'clock on every day. That's more like what a credit card setup would be. On this is the formula here. We can write all this down. We wrote down that formula. You could, if you wanted to write down again, it doesn't matter. This one, the amount, this is the total amount in the account or whatever. You just take the principal plus the interest. So that your total is just going to be, you add on that interest. Nothing really hard about that. You find the interest from up here and you add it on. My pen was right. You add it on to whatever the principal was beforehand. So, through the school here, I have a savings account that I keep track of. And it's got, let's say, $6,000 in it. Every month they add interest onto that, and the interest is usually about 78 cents. So all this is saying to do, once I find that interest, is I add it onto there. So I get $6,000 and 78 cents. Why does my pen not like writing? It's not back from break yet, I don't guess, is it? Then the next month, if I earn another 78 cents, it's gonna add another 78 cents to it. So on, so on, so on. It just keeps going that way. And you gotta watch, with that savings account that I'm talking about, for 5 or 6 years, that savings account was earning about 43 cents per month. So that was normal, and I just thought, all right, it's earning about 43 cents, whatever. They don't earn a whole lot. Then all of a sudden, 1 month it jumped up to like $1.78 that it earned that month. Confused the heck out of me. But I thought, you know what, I'm not going to call them and ask them because I'm earning about 4 times as much now as I was last month. I call them and ask them and they figure it out. I'm not going to earn that much anymore. But I probably should have called and asked them, because then here about 6 months ago, now all of a sudden the account started earning about 50 cents a month. And then I did call them and ask them, I said, why last month did I earn $1.78 in interest, this month I only earned 50 cents, what happened? I didn't change the account any, what's going on? And nobody could tell me, and they said, oh, we'll get back with you. Of course not. So I need to get back in touch with them and figure out, okay, why is it jumping around like that? But John deposits $6,300 in the account. How about your calculator so you can help me with this? We can get through this pretty quick. He's got $6,300 in an account that pays an annual percentage rate or interest rate of 3.5%. Determine the simple interest for 3 years. Our simple interest is going to be I equals P times R times T. We're looking for the interest, so that's just gonna stay I. What's the P in this case?
6,300.
6,300, very good. What's the rate this time?
5.
What are we gonna do to that 3.5? How many times you gotta bump it? Please make sure, because a lot of these are gonna be like this, you gotta make sure that you're bumping it twice. Every single time, you're bumping it twice. So it'd be 0.035. Ignore that stray mark going up through there.
Times 3.
And our time is always gotta be in years. Well, this time they told us how many years? 3. So punch all that into your calculator. That's gonna tell you the total interest, the total simple interest that you would earn over those 3 years.
661.5.
661.5.
Yeah.
Please make sure, again, when I graded the test before breaking stuff, I still got a lot of people just write that as their answer. Is that the answer?
5.
You got to make sure that you put that 0 on there. Now that's simple interest. Because if we left that money in there for 3 years, that's all we're going to earn. If it was compound interest, which we're going to talk about next time, we would do it for 1 year, and then that interest would get added back onto that principal, and we would make interest on the interest that we've already earned. All right? So you got to know when you're dealing with just simple interest and compound interest. But that's, for simple interest, that's all it is there. For a lot of CDs and stuff, that's the way it works. You're going to earn a set amount for those years, and it's not going to be any more or any less. Determine the amount of simple interest on the given principal for each amount of time. So again, I equals P times R times T. For this first one, what's our principal this time?
4,000.
Times, what's our rate?
6.
6%. How are we going to write that?
0.6. 0.06.
So 0.06. This time it's for 4 years. So what do we do?
Times 4.
Times 4.
960.
$960 even?
Yep.
So if we left that $4,000 in that account for 4 years, after those 4 years, we should have how much money in that account? 4,000 plus the 960, so 4,960. Now here's where you need to watch. You with me, Haley?
Yep.
What's different on this one?
4 months.
It's not a year.
It's not a whole year. The principal stays the same. The interest rate stays the same.
You just have to put a decimal.
How do we, if we want our T always in time, or in terms of years, how are we gonna put 4 months in terms of years? Give me a way that we could do it every single time. So that everybody knows, even if it's 3 months, 2 months, 1 month.
1 over 12, 2 over 12, 3 over 12.
Always put it over 12. You're always putting it over 12. So this would just be 4 over 12. Now when you go to punch this into your calculator, you're going to punch in the same thing, 4,000 times 0.06 times 4. You're going to get that answer. Well, that's going to give you the 960 that we just had up here, right? But then once you have that, then you're going to hit divided by 12, by that bottom number. 80? Anybody else get that? Does it make sense? So in 4 years, you earned almost $1,000. In 4 months, you earn about $80 in interest. That seems to be logical.
I guess 4 days.
4 days. Matt put this money in an account. He thought, man, he was all hyped up. I'm putting this money in this account. I'm going to leave it in there for the next 50 years. And it's going to be $1 million by the time I get done. 4 days go by and he's thinking, yeah, crap, I need this money. I want to buy this. Because that's probably what would happen, right?
Oh, yeah.
How are we going to put the time, if it's 4 days, how are we going to put that? So it's 4 out of 365. So if it's just in days, then you're just divided by 365 there. You do the same thing on your calculator, 4,000 times 0.06 times 4, then hit divided by 365 at the end. What's that give us?
2.6. Yeah, 2.63.
630. So something about like that. So Matt put the $4,000 in his account, had glorious plans of leaving it in there forever. 4 days later, he pulls it out. How much interest did he earn? $2.63.
I can go to get me a
$2.63. Does that make sense to everybody? Does it make sense that it would be $2.63?
Yeah.
Now, I guarantee Noah's doing this problem on the next test, and I have this on there. I guarantee that somebody's going to come up with $263 for that answer. You gotta stop and think, does that make any sense whatsoever that you'd make $263 in 4 days? Maybe if you got millions and millions of dollars, but on the 4,000, they're probably not gonna pay you 200 and some dollars for using your money for 4 days. Nathan Perez earned $220 in simple interest in 9 months at an annual interest rate of 8%. How much money did he invest? Guarantee I put a whole bunch of these kind of problems on the next test, because there's nothing hard about it. You just gotta understand how to deal with the numbers and how to use your calculator. What's different about this problem?
We don't
It gives
have
you the
it, and
interest.
so it's
We know the interest, we don't know the, so in place of I right here, what am I gonna stick in?
P.
220. Do I know P? Do I know R?
Yes, 8%.
So how do I write that?
0.08.
0.08. Do I know the time?
9 months.
9
9 out of 12.
Very good, 9 out of 12. Now when I do this, all you're gonna do, you're gonna take all of these things that you're multiplying together, and we're gonna divide this other side by it. You might want to do that first if you want. So on your calculator, just punch in what's 0.08 times 9 divided by 12.
0.06.
0.06, is that what you said?
Yeah.
Now, all we're going to do, to get P by itself, we're going to divide both sides by 0.06. What should happen to a number
Get bigger.
when you divide by something like 0.06?
Bigger.
Now, should it just get a little bigger? If it's 0.06, it's going to get a lot bigger. So what's 220 divided by 0.06?
3.66.
Say it again.
3.6. Repeating.
That don't sound right. That got smaller.
Oh. Oh. No? Yeah.
Calculator's getting lonely, Wes. Wait, want me to wake him up?
Oh, wait, 13.2.
13 what?
Point two.
Don't work, bro.
So if I write that 13.2, am I in agreement with that?
Yes.
Does that make any sense?
You say divide, hold on.
Does
Yeah,
that
it
make
should be-
sense?
I'm about to.
So the principle is, the amount of money that we put in the account, we need a zero here first, right? So we put $13.20 in the account. We earn $220 in interest.
That's not right.
It'd be nice if that's the way it worked, but it doesn't work that way. If I could go put $13 in an account and then 9 months.
$366.66.
That's what I said earlier.
That is not.
Yeah.
I said three. I don't wanna say, like,
Pretty sure you said 3.66.
no, I didn't, definitely didn't. I said 3,666.66.
What are we coming up with then? What is it?
3,666.
Oh, it's 220, not 22.
Was there other stuff, or was that it?
Point six.
Repeating, so we rounded off. Now, look at what we have. Again, make sure that your answer makes sense. So you put $3,700 in an account. And you earn 8% interest. Does it make sense after 9 months that they paid you an extra $220? Does that make more sense than the $13.20 that we had?
Yes.
Does it make more sense than $366 and whatever? Would it make sense that you put in $366 in an account and after 9 months they paid you $220?
No, because that seems like, that's a crazy amount.
That's a very crazy amount of interest, right, Simon?
Yeah.
So you gotta make sure, we're not dealing with loan sharks here, alright? That's what happens with a loan shark. If you borrow $366, then a month later, you owe them an extra $220. Alright? You're not supposed to be allowed to do that anymore. Credit cards, when President Obama was in office, he put in some kind of law that knocked down the credit card interest, because credit card interest was just really, really getting sort of ridiculous, where they were charging 30, 40, 50% interest on these credit cards. And the people who were getting the worst of it was people about your age that were going off to college, and as soon as they get off to college away from mommy and daddy, and then the college, in their college mail, they're getting all these, oh my God, I can start a credit card. And they fill it out, and now they're 18, and mommy and daddy can't come back and say, no, you can't have this credit card. So now these college students got these credit cards, and they go out and they run it up real quick. And then all of a sudden, 2 months later, they had a $5 spending limit on it, and they spent all $500 on it. 2 months later, they owe this company like $1,500 because they had such a high interest rate on it. Again, you gotta make sure that this stuff makes sense. Does it make sense? We put $3,500 in an account that they're gonna pay us $220 in interest. Yeah, at 8% probably. You're not gonna find many savings accounts or something like that that have an 8% interest. They're not gonna pay you that much. Now, a credit card account, yeah, it's gonna be a lot more than 8%. It's probably, most credit card accounts now are, and they're getting back up there again, but they're between for my credit card accounts, it's like 13 to 18%. If you guys went out and got a credit card today, probably more like 18 to 24% in interest that you'd pay. That's the assignment on page 223, 213, and 15. Do we want to work problems together, or you guys just want to work them on your own? On your own?